the 5-minute theory, condensed and simplified about network graphs. So you see a bunch of circles with lines, right? Let me do a laser pointer. So imagine each circle represents a community of people. So you have one community here, you have one community here. And so let's give them some names. So you have community A that travels to this circle either for work or for school or just to go to the mall, right? Some circles are big and some circles are small. This denotes the size or the number of members in a community. Clear ba tayo so far? Are we okay? So you will see that communities, which are the circles, are connected by lines. So these are the travel routes, the migration patterns. It shows that the community A travels to this circle via this route. All right, clear tayo, ha? Now, we've all heard about, or the people with medical background, you've all heard about the R naught, which is the reproductive number of COVID. And presently, it's anywhere between 1.6 to 1.8, which means that one person infected can infect 1.6 or 1.8 persons more. This is how fast it spreads. Now, the thing here is we will show that, let me call up a color, blue. Let us suppose that community A over here, let me change the color. Community A over here is the first one to get COVID. And for the sake of argument, let's say it takes 1 week for a community spread to reach the next nearby community. Okay, clear pa tayo so far, ano? So after 1 week, it will infect this node. All right, after 1 week, community A infected with COVID will infect this community in 1 week. So not too bad. But then what happens on the second week? By the second week, by definition of the algorithm, this node over here or this community will have then infected this node, and this node. So we are now on our second week. We are showing the progression of COVID week by week. Then we choose another color. So we are on our third week. By the third week, the community D will have spread it to their communities, and it will cross over to a major metropolitan area called, let's say, B. This is the third week. Now, let me use another color, dark green. On the fourth week, you will notice that COVID is now spreading to more communities faster because COVID now reached a major community or major urban area called B. Once it reaches B, by the next week, it will spread here, 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 and cross over to community E. This is now our fourth week. By the fifth week, it will have spread to this subcommunity cluster and this cluster. And then on the sixth week, it will now have spread here, 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 and here. So if the original COVID hits A, it will take 6 weeks to spread all over our country, for example. And this is the same R naught. Huh? We're not changing the R naught value. Now, what happens, though, if instead of A, COVID first lands here in B? Well, to save you, the shortcut is, I can show you, it will take only 3 weeks, not 6 weeks. So let me select a color. It will now take 3 weeks instead of 6 weeks. Now, why? Because once you hit a super spreader area like B, in the first week, it goes here, 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 and here, and here. So in the first week, it spreads to 1, 2, 3, 4, 5, 6, 7 communities all at once. And what happens on the second week after that? From C, it will have spread to this community. And from E, it would have spread here, here. And from D, it would spread here, 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 and cross over to this other major metropolitan area. And this is the second week. And finally, on the third week, it spreads to A, here, and here. So we are showing here one insight is that even if your R naught is constant, depending on how fortunate or unfortunate you are, depending on where it lands, which community it lands in first, you could either see a 6-week spread or a 3-week spread.